All right, we're working lesson 11-3, which is called Vertex form, and the purpose of this lesson is to learn how to take a standard form quadratic and turn it into a quadratic in vertex form. And what's the advantage of having a quadratic in vertex form? Once it's in vertex form, you can describe the transformations. So I've copied the steps here from Springboard. I'm going to kind of add to them a little bit. I also have this same problem over here solved by completing the square, and the reason that I wanted to compare the solving by completing the square to the converting to vertex form is because they both involve completing the square, but there's a little bit of difference. And so I don't want you to get the process of solving by completing the square confused with changing to vertex form because that's what we're doing. We're doing this by completing the square. So remember, completing the square just means that I'm going to create a perfect square trinomial. And you know that you cannot create a perfect square trinomial if you have a leading coefficient right here. So the fact that there's a 3 right there is what lets me know I have to get rid of that 3, because you can't complete the square with the 3 right there. Over here, when we were solving, we just got rid of that 3 by dividing everything by 3. Here we're not going to get rid of it, we're just going to factor it out of the way. And I'm going to factor it out of the way just of these first 2 terms, because they're the ones that I'm going to use when I'm completing the square. Okay, so now I've got this. This right here is the exact same equation as this right here. Everything's the same, it's just been rearranged a little bit. Now it says that you know how to complete the square. We want to make this a perfect square so that down here we can write it as, in this factored form. We already know that we're going to have a 3 out there, and we know that we want to be able to go from here to here. But we've got to create that perfect square right there, and you know how to do it. We take half of the 4 and then we square it. So when we take half of that 4 and we square it, half of -4 is -2. -2 squared is +4. So we're going to rewrite this problem right here. This is just, this is my thinking, okay? It's not really where I haven't written down. This is my thought bubble, okay? So here, I know I'm going to put a +4 right there. That just made that a perfect square. Well, we added a 4 inside that parentheses, but did you notice that that parentheses, remember, is being multiplied by that 3? So really, what I just did was I took this equation right here and I added 12 to it. Where did the 12 come from? Well, I put the 4 inside the parentheses, and then I have to multiply 3 times 4, so I took that equation and I added 12. That means I've changed the value of that equation. So what I have to do now is subtract what I added in. Since I added in a 12, I got to take that 12 away. Now I'm going to show you a step that I normally do in between here. When I do this step right here, I normally go ahead and put minus and then 3 and a parentheses. Well, why did I put minus? Because I know I'm about to add a value right here, and it's 3 times some number. So I know I'm going to have to take away that number eventually in order to maintain equality. So what I'm doing is I'm adding 12, and then I'm subtracting 12. Adding 12 and subtracting 12 means I don't change the value of that equation. So I needed to add the 4 so that I could get a perfect square right here, but I got to subtract the 12 away, because that 3 times 4 is 12. I got to subtract the 12 away so I don't change the value of my equation. I can't change the value of my quadratic. So I'm adding 12 right here, subtracting 12 right there. Now the whole point of having this is so I can do this. And then, of course, I can put the +7 and the -12 together and get -5. Okay. So, to maintain the value, this right here was step 3. This was step 3 right here. And then write the trinomial inside the parentheses as a factored square. So that's what so this is step 4. All right, that was kind of quick, so let's do another one real quick. Let's do f of x equals 2x squared. Let's do plus 12x plus 1. All right, so step number 1 would be to factor out the 2 from the first 2 terms only. Put a plus and a blank. I've got a plus 1 right there, and then I'm put a minus 2 times my blank. This blank right here is going to be multiplied by a positive 2, so I'm going to have to take that away. So I create a space, I factor and create a space, and then step number 3 is I'm going to fill that space. So what goes right there? Half of 6 is 3, 3 squared is 9. So if I put 9 right there, I put 9 right there. Okay, if I have a 2 in front of this parentheses, I need a 2 in front of that parentheses. Now I'm going to simplify everything. The whole point of making that a perfect square is so I can factor it, write it in its factored form. And then negative 2 times 9 is negative 18. Negative 18 plus 1 is negative 17. And there's the factored form. We see it's got a vertical stretch. It's shifted left 3 and down 17. So that's how you, those are the, 1, 2, 3 steps to putting it into vertex form.